Let's go through LeetCode 3181. Maximal total reward use operation 2. For this question, it gives us an integer array rewards values, and we can select those kind of values, right? So it say that we can select unmarked, and that means we can not select multiple times. And initially there is an x equals to 0, and if we select our rewards to x, our x will be updated. And next time we select the rewards value should be greater than x, so that we can add to our x. It asks what's the maximal total rewards you can collect. Comparing to the maximal total rewards using operation 1, the data range is kind of big, 5 to the power 4th, right? So we know for this kind of range, we will say if we will say we are going to open if it is like a backpack problem, right? So there are n items, and the max will be 5 to the power 4th. So if the maximal value is this, we should open capacity to be 10 to the power 5, right? So it will be n multiplied by this kind of range time complexity for the 0, 1 backpack problem, right? But the things that we can still do the optimizations to write to get this kind of question passed. Just do some change based on the maximal total rewards using operation 1. So how can we do that, right? So we know the first thing is that we should dedupe first. If there is a number, they have duplicates, right? If we add this kind of number to our x, the next, now our x should greater equal to this kind of number. So that means that those kind of duplicates will not be greater than x anymore, right? So what we do is that we should dedupe so that our data set can be small. So that we are going to, that means that as we talk about, the order matters, right? So because if we add x1 first, we're still able to add 3, right? But if we add 3, current x is 3, we're not able to add 1 anymore. So we should also sort, right? So if we want to sort, let's use a tree set to sort. And also we have a max here, right? Because our capacity will be 2 multiplied by max, and instead of write 10 to the power 5, right, equals 0. So what we do is that for every reward values in we'll say if set can add reward, right, then we are going to have max equals max.max set reward. And we're going to have a DP, right? Use a Boolean. For we talk about there are 2 dimensions for this kind of DP, and one dimension is how many items, right? So that will be the tree set size, and another is the capacity or the weight, right? But we say this is 0, 1 back problem, and we can optimize to only the dimension with capacity, right? So one of the improvements is that instead of write 10 to the power 5, we use 2 multiple max, right? We say dp 0 equals true. So then what we do is that for every value in set, right? Remember for the maximal total rewards using optimal operation one, what we write for int j equals 2 multiplied by max minus 1, right? And j greater equal to 0. And j minus minus, right? What we write it before is like this. Let's say if j is smaller than value and j plus value smaller than 2 multiplied by max. And actually, this second question can be ignored, right? Because we already have every j will be smaller than max. Also, value will smaller equal to max, right? So actually, we don't need this. Then we'll have dp j plus value all equal to bpj, right? So this is the way we write in 3080, right? The 1. Then what we do is that for int j equals to 2 multiplied by max minus 1, j greater equal to 0, j minus minus, right? We'll say if dpj, we just return j, right? Otherwise return 0. But this will still TLE, right? We still need to have some kind of optimizations here. Doing like this, it will still TLE because for every item, we are going to iterate to 2 multiplied by max. So you'll see this will TLE. But we say 0, 1 backpack. For the inner loop, right, we should do reverse order traversal. But the thing is that you'll see why we should do reverse iteration, because every dpij it coming from dpi minus 1 and j, and I minus 1 j minus value, right? So what we worry about is that in the new line, this kind of dpij may update those kind of dpi I minus 1 j minus value already, right? So this part may be update so that when we do the forward traversal, this value is calculated from here and here, here and here, right? And in this case, this may not be correct, right? But for this question, we have the condition that j is smaller than j smaller than v, right? Then we are able to update. So that means we can only add to this part j plus v here, right? And also this j here, that will never have an overlap. So we don't need to worry about the second line being updated to a new value, because this part will never have any overlap to here, right? So for this question, actually we can still do for the inner loop, we can still do the forward iterations. So if we do forward iteration, we can write this, right? So we don't need to from j to from max. We just need to write for j equals to 0, j smaller than value J++, and we'll have DP if DPJ, right? And DPJ plus value equals to 2. In this case, our inner loop will only have half of the data, at most half of the data, right? Because every value will smaller equal to 2 multiple by max. So doing like this will have at least to the data range will be much smaller. So doing like this kind of improvement, we are able to pass. But the things that remember that for 0, 1 backpack problem, for the inner loop, we should normally still iterate from the large to smaller, right? For this question, we are able to iterate from smaller to bigger because we have condition J smaller than value, right? So that the DPJ and the DPJ plus value, they will never have overlap, right? And also for the J smaller than value, right? We will never have overlap. Yeah. So we know for 0, 1 backpack problem is from the upper and the left upper, right? And so this will be one of the improvement which can get our code passed. But we talk about this data is very it's a big size, right? And if we can use some kind of binary format to do the operations, use the for example, some kind of binary format, dp0 equals true. That means we have 0, 0, 0, 0, 1, right? We set this is index 0. And so that is weight 0 is always at the beginning, weight 0 is always achievable, right? And if we, in a state, for example, for the ith item, we have some kind of binary format like this, right? Means we are able to achieve weight 0, weight 1, not able to achieve weight 2, but we are able to achieve weight 3 and weight 4, right? So for this kind of ISO item, it has a weight. For example, it has a weight 10, right? Has a weight 10. That means for every J smaller than 10, right? That means we look at the from 0 to 9, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we look at this kind of range. Those kind of data, now we are trying to add item which is weight 10, right? Those are just for the X to be smaller than 10, right? They are achievable or not. And once we have a new item coming, right? That means this kind of 10, right? We should be able to use this kind of binary to see if they are able to achieve to this one, right? So if this kind of binary is 110, 110, 110, 110, 11, right? So that means this part should also have 10, 110, 110, 11, something, right? And also at its original, for example, original it is have one here, right? And have one here, right? So this part will be composed from here and here, right? So we just use binary format to represent this kind of Boolean array. And we know for Java, this kind of integer can only have 32, right? 32 length. And long can only have 64 length, right? So we need to have some very big range. So we have to use some kind of in Java something called big integer to do this. And big integer initial state that is big integer dot one, right? And we need to cut for every item v, right? Cut this kind of v minus one, right? Part and shift this one to here, and then to do all with original this kind of banner. So let's write code for this. So what we need is just to change this part. We are going to use a big integer number, right? Equals big integer dot one. That means initially we have dp0 equals true, right? So that is this one. So this big integer, it may have 10 to the power 5 elements in it, right? 0 bits. And what we do is that for every value, right? For every value in this kind of solid array set, right? We're going to have let's first get this kind of part, right? So we should use 1111 to be here, and use this one to end with our number, right? We get this part, right? So let's call something called mask, which is 0, 0, and to this kind of v there are v digits here, right? And use this one to end with this number to get this part. So let's call big integer. So mask, that will be big integer dot one for the shift left v, and subtract big integer dot one, right? So well, no, what does this one mean? This one means that actually trying to if there is no range limitation, let's say if it is for example long, right? We are just if long is enough, what we are the mask, we may write something like one left shift v minus one, right? So this is the same meaning with this. But for Java, this kind of range is not enough. But Python, we can still write mask like this. And then we should get this part. We should use the AND operation, right? So we'll say big integer lower part, right, equals number dot and mask, right? And our number for this round should be number with operation, right? Or operation with lower to shift the left V operation, right? And in the end, we just need to get this number's length, length minus 1, right? Because that is our biggest number we can reach. So and also the big integer, we need to import java.max, right? Or big integer. So do you like this kind of improvement? We are also able to, it should be value, should also be able to pass. There is some kind of improvement, but not big, right? Because the time complexity for a big integer, it is actually not improved the time complexity. It is the way it being passed is that because Java do some optimizations and bit operations, right? To do add or subtract or add or operations. And in the bottom layer, it uses some kind of command, machine command to do those kind of operations. But the disadvantage of this part, this way is that it need to import some kind of bigger integer package for Java, right? But for Python, because there is no range, we can write those kind of mask, right? Like this easily, right? So let's write this kind of things in Python. So in Python, what we do is that we'll have num equals 1, right? So we'll say for value in sorted, right? Sorted, let's set this one as set and the rewards value, right? Then we are going to have mask equals 1 left shift will be -1, right? And also we'll have lower part. Lower part is our number and mask. And our new number in this round should be this one O equal to our lower left shift read, right? And in the end, we just return number dot bit length -1, right? value. Lower. It is very fast for Python because Python, this kind of AND or OR operation, it may be, I'm not sure possibly that is a one operation, but it do a lot. In Java integer, big integer, I'm not confident what is the button, how it is represented, whether it is a one or not. But Python, this kind of way use binary to represent is much faster. So this will be one of the approach to do this kind of question, right? This is another way to do the DP optimizations, right? So we'll say one of the ways that we dedupe and use a forward inner loop, and in Java that is also passed, right? Another is that we use big integer to represent those kind of DP array, and they passed. One of the things when I read the discuss, right, and there is a solution doing binary search. I look at the algorithm for it. It is trying to do a DFS, right? Trying to DFS get some kind of limit. The thing is that there are some actually when I read this solution, I also get some kind of inspirations. That one of the inspirations is that the last biggest element will always be get. Will always get the biggest element, because if we have x, right, and if we are not get a number n minus 1, if we get a number n minus 2, right, we for the x we can still keep that. That means if we final result is x plus number n minus 2, then we can just replace n minus 2 and n minus 1, right? So we keep the previous x part to be the same. So I think one of the conclusions for this kind of binary search way is that the last element will always be added to our final result x. But it use some kind of limit, right? And also the things that if we find this limit, for example, the last one is 2000, right? And in the previous one, we just find 1999. That means we can return 3999, right? Because the result will not be bigger than this. And keep doing like a minimal at a limit to this, right? Then iterate just recursively to call get rewards. And he also added some kind of binary search, right, to find the first index greater than this. This way, it is actually this way. I would say I think about this. It passed. This kind of solution it passed. Actually, when we sum it, it passed, right? And also very fast. But this is not correct, because I have a demo case which for this one, right? From 2 to this, right? When we run this, it will actually get a TRE. So what I think about is that this kind of we don't have enough test case for this, and also I I think he did some explanations here, right? And I also, when I read, I understand what he's doing, but I think that this is not correct. And also his memo is not never been used. But I'm not saying using memo cannot solve this problem. This may be some kind of approach which can solve this problem, right? Maybe, but just this solution is not correct, I think. Even even because for this kind of data set, it's not not passed, right? It will still tell you. Just and the problem does not have enough test cases. But if we have time, I think we can still think about the DFS and memo way to solve this problem, because what I think is that if in some kind of range, right, we can achieve some kind of x, right? We should not calculate again. But the thing is that this kind of x we achieve should also depend on some of the index, right? So let's say if previous to this kind of index, we are able to achieve this kind of x. If we save this kind of do some way to iterate and save this x value, and we can put this into our map as memo to improve the efficiency. So that may be an approach. Okay, so so this is my talking about this question.